In order to achieve our autonomous objectives, we are using several control components on our robot this year. Camera vision. We knew that camera vision would be the most efficient way to detect the number of rings in the ring stack this year. We tested 3 different methods for this: threshold, contours, and TensorFlow. The threshold method uses OpenCV, an open source camera vision library, and measured the amount of yellow light coming in through the camera. The more yellow light, the more rings in the stack. However, the camera needed to be positioned in the exact same position every time. The contours method also uses OpenCV and outlined the edges of the ring stack, called a contour. The height of the contour determines the number of rings in the stack. We also used the first provided TensorFlow program, but that proved to be inconsistent, so we stuck with the contour method. PID controller. A proportional integral derivative controller, or PID, is an error mitigation controller in which the closer you get to the target value, the slower you are able to approach it. This helps prevent overshooting and keeps the system where we want it to be. We use this controller to keep our shooter velocity consistent. We used to use a PID controller with the IMU sensor, but we phased it out once we started using Roadrunner, which we'll go over next. Motion profiling. Motion profiling is a controls algorithm that defines a system's movement at every point in time. It allows us to take the physics of our robot, such as the maximum acceleration, into account when planning robot movements. This allows for extremely smooth and precise movements. Our team uses Roadrunner to accomplish this. Roadrunner also allows us to plan out our robot path in a series of trajectories, which can be curved or straight. Odometry. Previously, we were using drive encoders for our autonomous localization and positioning. However, we realized that this did not account for wheel slippage. As a result, we are now using dead wheel odometry. Our odometry pods consist of a rev through-bore encoder connected to Omni wheels that are sprung against the ground to prevent wheel slippage. We have 3 of these to account for X, Y, and heading. This allows us to track our robot across the field with extreme accuracy. Driver enhancements. To make driving easier, we have implemented a slow mode and a super slow mode so that the drivers are able to make fine adjustments when shooting. Our shooter velocity PID also runs during teleop to ensure consistent shooting. In order to make shooting easier for the drivers, we have made it so that one button runs a sequence in which the robot will rev up the shooter, shoot 3 rings, and rev the shooter back down. Thank you for watching our control video.